NASA revolutionized space exploration, but is it time for the agency to stop designing and developing rockets? Hi, I'm Chris and welcome to Orbital Frontiers. From landing astronauts on the moon to assembling the International Space Station, NASA has played a critical role in advancing humanity's presence in space. These groundbreaking achievements were made possible by iconic launch vehicles like the Saturn V and the Space Shuttle. Today, NASA aims to return American astronauts to the moon with the Artemis program, relying on the new expendable heavy-lift rocket called the Space Launch System, or SLS for short. Drawing inspiration from past programs and reusing components from the Space Shuttle, SLS represents NASA's vision for deep space exploration. However, the program has been plagued by significant delays and skyrocketing costs, with each launch estimated at an astounding $4 billion. So with private space companies leading the way in reusability and cost efficiency, we have to ask, should NASA continue developing the SLS, or even launch vehicles at all? NASA's legacy in space exploration is unmatched, built on a foundation of revolutionary launch vehicles that pushed the boundaries of what humanity thought possible. It all began with the Redstone and Atlas rockets, early launch vehicles that carried America's first astronauts into space during the Mercury program. Both rockets were originally ballistic missiles adapted by NASA for human spaceflight. The Redstone launched Alan Shepard on the first American suborbital flight aboard Freedom 7, while Atlas carried John Glenn as he became the first American to orbit Earth aboard Friendship 7. Building on this success, NASA developed the Titan rockets to propel the Gemini program. The Gemini program was essential for perfecting critical techniques like orbital docking and spacewalks, achievements that laid the groundwork for the Apollo program and beyond. But the true pinnacle of NASA's engineering came with the Saturn rocket family, most notably the Saturn V. Standing over 363 feet tall and 33 feet in diameter, the Saturn V held the title of the world's most powerful rocket for decades, capable of launching over 140 metric tons into orbit. This engineering marvel powered the Apollo missions, culminating in the historic Apollo 11 moon landing in 1969. Following the Apollo program, the Saturn V had one final mission, launching America's first space station, Skylab, on May 14, 1973. After that, budget constraints and shifting priorities led to the retirement of both Apollo and the Saturn V. NASA shifted its focus to reusability with the Space Shuttle, first launched in 1981. The Shuttle was a groundbreaking vehicle designed to carry astronauts and cargo into low Earth orbit and return safely to Earth. It was instrumental in constructing the International Space Station, repairing the Hubble telescope, and enabling numerous scientific missions. However, following the tragic Challenger and Columbia disasters and mounting operational costs, the Shuttle program was retired in 2011. From the Redstone and Atlas rockets to the Space Shuttle, NASA's rockets have not only shaped human space exploration but inspired generations to dream of reaching the stars. However, as we'll see, challenges with NASA's latest rocket, the Space Launch System, raise questions about whether this legacy should continue in the same direction. After retiring the Space Shuttle, NASA planned a new generation of rockets under the Constellation program, introduced in 2005. This program aimed to continue human spaceflight and prepare for deep space exploration with two rockets, the Ares 1 and the Ares 5. Ares 1, the crew launch vehicle, was designed to launch the Orion capsule for human missions, while Ares 5, the cargo launch vehicle, would carry supplies into orbit and beyond. However, the Constellation program was canceled in 2010 due to funding issues, with only one test flight of the prototype Ares 1X. From the ashes of Constellation, NASA developed the SLS, later dedicated to the Artemis program, aimed at returning humans to the moon. Inspired by the Ares 5, the SLS was built using components from the Space Shuttle program. The rocket's first stage would be propelled by repurposed RS-25 engines, while its boosters are derived from the Shuttle's solid rocket boosters. In its debut launch on November 16, 2022, the SLS earned the title of the most powerful rocket ever built, capable of launching about 95 metric tons to low Earth orbit and 46 metric tons to lunar transfer injection. But despite this milestone, the program has faced delays, cost overruns, and criticism. SLS was initially slated to launch in late 2016, but repeated delays pushed the timeline back by several years. These setbacks were caused by manufacturing challenges, evolving NASA requirements, and issues with the mobile launch platform. The delays not only disrupted schedules but also postponed key Artemis missions, including the long-awaited return of astronauts to the lunar surface. Cost is another major concern. Originally estimated at $10 billion, development costs have now surpassed $25 billion, with each launch projected to cost an eye-watering $4 billion. By contrast, private companies like SpaceX are redefining cost efficiency. The Falcon 9 launches for just $67 million, while the fully reusable Starship, the world's most powerful rocket, is expected to reduce costs to around $2 to $10 million per launch. SLS's reliance on expensive and outdated technology further complicates its case. The RS-25 engines initially developed in the 1970s for the Space Shuttle require extensive refurbishment, adding to cost and delays. Similarly, the solid rocket boosters, while powerful, limit innovation compared to modern reusable systems. The program's contractors, Boeing and Northrop Grumman, have also faced scrutiny. Boeing, responsible for the core stage, has been criticized for inefficiencies and mismanagement. Meanwhile, Northrop Grumman's reliance on legacy designs for the boosters has raised concerns about the program's ability to innovate. Both companies have faced accusations of inflating costs and contributing to delays. These challenges have led to growing frustration from both the public and industry experts. Many argue that SLS represents an outdated approach to space exploration, especially when private companies are achieving more with less. So with these setbacks, should NASA continue investing in SLS, or is it time to consider alternative paths? In recent years, private companies have taken the space industry by storm, achieving feats that were once the exclusive domain of government programs. At the forefront of this revolution is SpaceX, a company that has redefined what rockets can do and how much they should cost. SpaceX's Falcon 9 was the first orbital rocket to achieve routine reusability, drastically cutting the cost of access to space. When its first stage is reused, Falcon 9 can carry up to 19.3 metric tons to low Earth orbit. In a fully expendable configuration, this increases to 25.1 metric tons. With over 200 successful launches, Falcon 9 has become the workhorse of the modern space industry, and SpaceX isn't stopping there. The Falcon Heavy, another SpaceX innovation, is currently the most powerful operational rocket. When the boosters are reused, Falcon Heavy can carry 63 metric tons to low Earth orbit, while a fully expendable configuration increases that capability to 70.3 metric tons. This versatility makes it ideal for launching heavy payloads, including satellites and interplanetary probes. At approximately $97 million per launch, Falcon Heavy offers unparalleled value compared to traditional heavy-lift rockets like NASA's SLS. SpaceX's next-generation rocket, Starship, aims to revolutionize deep space travel. Designed for full reusability, Starship can carry 100 to 150 metric tons to low Earth orbit. In the future, expendable configurations may allow for even greater payloads. With a projected cost of just $2 to $10 million per launch, it could fundamentally change how we explore the cosmos. But SpaceX isn't the only player in the game. The United Launch Alliance, a joint venture between Boeing and Lockheed Martin, is developing the Vulcan Centaur, replacing their legacy Atlas V and Delta IV rockets. Vulcan boasts a payload capacity of up to 27.2 metric tons to low Earth orbit. Reusable configurations are planned for the future, incorporating a smart reuse program where the BE-4 engines will separate during flight and eventually be recovered. Meanwhile, Blue Origin is focused on reusability as well. Its New Shepard rocket, designed for suborbital missions, carries up to 1 metric ton for research payloads, or 6 passengers for space tourism. Looking to expand its capabilities, Blue Origin is developing the New Glenn, which will deliver up to 45 metric tons to low Earth orbit in its partially reusable configuration. Then there's Rocket Lab, a leader in the small satellite market. Its partially reusable Electron rocket, optimized for lightweight payloads, carries up to 661 pounds to low Earth orbit. The company's upcoming medium-lift Neutron rocket will expand Rocket Lab's capabilities with a payload capacity of 15 metric tons to low Earth orbit in reusable mode, increasing with expendable configurations. Beyond these established companies, a wave of emerging players is pushing the boundaries even further. Companies like Relativity Space, which is building 3D printed rockets like the Terran R, demonstrate the growing diversity and innovation within the private space sector. NASA has already embraced this transformation through public-private partnerships. SpaceX's Crew Dragon, developed under NASA's Commercial Crew Program, has proven to be a cost-effective and reliable solution for transporting astronauts to the International Space Station. These collaborations not only share costs, but also drive innovation at a pace rarely seen in traditional programs. With the private sector delivering groundbreaking advancements in cost, efficiency, and reusability, it begs the question, should NASA focus on building rockets, or can these companies take on that responsibility while NASA shifts its focus to exploration and science? The Space Launch System has consumed a significant portion of NASA's budget. By phasing out SLS and reinvesting those funds, NASA could accelerate its progress towards its most ambitious goals. One solution is to reinvest it back into the Artemis program. Instead of spending billions on rocket development, NASA could expand contracts with private companies like SpaceX, which is already developing Starship as the program's lunar lander. Additional funding could also be directed toward building critical lunar infrastructure, such as life support systems, habitats, and advanced rovers. These investments would ensure that humanity's return to the moon is sustainable and sets the stage for further exploration. But Artemis is just the beginning. Redirecting funds from SLS could enable NASA to pursue other groundbreaking missions. One key area is the development of advanced propulsion systems, such as nuclear thermal and ion propulsion. These technologies have the potential to revolutionize deep space exploration, reducing travel times and making missions to Mars and beyond more practical. NASA's expertise lies in deep space exploration, from studying distant planets to discovering the origins of our universe. With additional resources, NASA could launch more missions like the James Webb Space Telescope, sending advanced probes to explore outer planets, and finding the next place humans could call home. These missions don't just expand our understanding of the cosmos, they inspire the world to dream bigger. Another critical area for reinvestment is planetary defense. NASA has already made progress with missions like DART, the first test of an asteroid deflection system. Additional funding could accelerate the development of early warning systems, asteroid tracking networks, and next-generation spacecraft capable of deflecting potentially hazardous objects. Protecting Earth from cosmic threats is not just a scientific priority, it's a responsibility. By focusing on advanced technologies, exploration, and planetary defense, NASA can strengthen international collaborations and lead humanity into a safer and more innovative era of space exploration. Phasing out the SLS and redirecting those funds isn't about abandoning NASA's legacy, it's about building on it. By prioritizing Artemis and investing in the technologies that shape our future, NASA can continue to inspire generations while achieving its boldest goals. For over 6 decades, NASA has been at the forefront of space exploration, inspiring the world with its groundbreaking achievements. From the first footsteps on the moon to unraveling the mysteries of the universe, NASA's legacy is a testament to humanity's drive to explore the unknown. But as the space industry evolves, so too must NASA. The challenges facing the Space Launch System highlight the need for a new approach, one that embraces the ingenuity and cost-effectiveness of the private sector, while allowing NASA to focus on its greatest strengths: exploration, science, and innovation. The Artemis program represents a bold step forward, with plans to establish a sustainable presence on the moon and lay the groundwork for missions to Mars. By redirecting resources from rocket development to these critical goals, NASA can achieve its vision faster, safer, and with greater technological advancements. Beyond Artemis, the possibilities are endless. With investments in advanced propulsion systems, we could reach Mars more efficiently. By exploring distant planets and icy moons, we could uncover the secrets of our solar system, and by strengthening planetary defense, we could safeguard the future of humanity. NASA's mission has always been to lead, to inspire, and to push the boundaries of what's possible. Collaborating with private companies and international partners doesn't diminish that mission. It enhances it, allowing NASA to do more than ever before. The question isn't whether NASA should design and build rockets. It's whether NASA should focus on building the future. By embracing this shift, NASA can ensure its legacy endures as a beacon of hope, innovation, and exploration for generations to come. Again, my name is Chris, and thanks for watching the video if you made it this far. If you enjoyed this type of content, please feel free to subscribe, leave a like, and continue the conversation on NASA's path forward in the comments.